Algebra 1, Lesson 37. Part A is just called Inequalities. So, symbols of inequality. Well, we have not equal to, less than, greater than, we also have less than or equal to and greater than or equal to. It does include, can equal, but also can be less, or it can be equal, but also can be greater. So those are still inequalities. Just like equations, inequalities can be true, false, or conditional. Conditional means it's going to have a variable. So sometimes it's true. It depends on what the variable equals. Alright, so the solution set of an equation or inequality is a set of all numbers that satisfy that equation or inequality. Solution set. And you already know that sometimes there's more than one solution to an equation. There are many, many solutions to inequalities. Okay, that's all we're going to do for Part A. Part B is talking about greater than and less than. And so you see this number line. We're going to graph a couple of numbers on this number line. We're going to graph -3, which means we put a dot right at -3 on the number line. And by the way, the dot is the graph. And the number that it's at is the coordinate. Okay, so we have graphed -3 on this number line. We're also going to graph -1. Okay, so that dot is also the graph, and -1 is its coordinate. Alright, and the point of Part B basically is, if you see these numbers graphed on a number line, it's very easy to see which one's greater, because the greater number is always to the right on the number line. Let's just put greater value is to the right on number line. Okay, pretty much that's all for this. Now, you may have noticed I don't have arrowheads on the ends of my number lines, and you're probably used to having those, but we're about to get into graphing solutions of inequalities, and they have their own arrows, and just so it's very clear what our actual graph of our solution set is, the book does this also. I just don't have arrows on the ends of my number lines. They do keep going. Okay, so in Part C here, like I said, graphical solutions of inequalities. Look at example 1. Draw a number line, it's already there for you, and graph the solution of x is greater than 2. Okay, there's no line under here, so it doesn't mean greater than or equal. X cannot equal 2. So I need to graph everything that's bigger, greater than, which means to the right of 2. That does not mean I start at 3, because 2.5 is also bigger. 2.000000001 is also bigger. I'm going to put an open circle, not a point, because that would say it equals 2, but I put this circle, which means this arrow I'm putting over here gets infinitely close to 2, but it doesn't touch it. That circle's like a buffer. Okay, and I am putting an arrow on that because it keeps going, and so the graph of the solution of this is any number bigger than 2, so it keeps on going. That's the graph. Okay, next one, I did not give you a number line. Draw a number line and graph the solution of x is less than or equal to 2. So I'm putting this, and by the way, you don't always have to have 0 in the middle of your number line. I'm going to put this number in the middle of my number line. Okay, 0, 1, 2, 3, 4, they're not spaced very evenly, but here's my number line. And it's allowed to equal 2, so I'm putting a dot on the line at the 2, and then less than. So, to the left. There it is. It's been graphed. All right, last one. Now we're given a graph, and we're supposed to come up with the inequality that matches it. Okay, so we see an open circle at -1, and it's going to the left. These numbers are less than -1. Open circle says it doesn't equal -1, so this is it. That is the inequality. Now, whenever you've done these, the graph should match, and a way to check that is pick some numbers that are graphed and make sure that they make this inequality true, because they are supposed to be the solution, which means they make it true. So -4, I could put that in place of here. Is that less than -1? Yes. And then I could have checked my graphs up above here to make sure, like some number that I graphed, does it really make that inequality true? And if it does, then I know I got it right. That's all there is to lesson 37. See you soon.